Okay, so now that we believe we're getting the username right here in this code over here, what we want to do next is have a functional way to print that information. And again, we're going to imagine that the ZIO console type doesn't exist. So in the real world, remember that the ZIO console type does exist, but for what we're doing, let's imagine that it doesn't exist. And we know we want to do something like print a string. I call it print name here, and that's actually a little too specific. What it could just be is print string or print line. So we can imagine that we're going to have a function over here. I guess I'll just call it print name because that's what I use there, and I'll try to be consistent with that. So this one's going to take in name, which is a string. And then what I do in the book is I say, we know it's going to be some sort of ZIO over here, and then it's going to be some use of print line down here. So those are two of the initial questions we're going to work with. And what I do here is we know that this is going to be print line name, but this guy right here returns a unit. And because that's a side effect, what we want to do is wrap that in a ZIO. And knowing that this is a unit, you could probably guess that it can't fail. So as I mentioned before, you wrap this in a ZIO, but this one's going to be called a ZIO.succeed. And again, that's because this cannot fail. So this is the body of the function. And now we want to come up here and just as a little exercise, I want to fill in these parameters over here. So again, that first parameter is R. So if I type those in there, REA. And the first parameter is R for the environment. So as you've seen before, this doesn't need any environment. So what do we use there when it doesn't need an environment? We use the type any. And then you can think of these next two parameters here as being the either type. So the left parameter inside that either would be the failure value. But because I've stated that this cannot fail, what we use up here I haven't shown yet. What we use here is the nothing type. So you use nothing when you're declaring that this code down here can't really fail, even though it's an effect. It can't fail unless, as I mentioned before, unless your computer is about to fail. And so then when we come up here to fill in these two types here, that can't fail, so we use nothing. Again, that's just the standard. Just like any is a standard for not having any environment coming in, nothing is a standard for having a value that can't fail. And then because the body of the function just consists of a print line, can you imagine what the success value over here would be? And if you said unit, that is correct. And that's because print line returns unit, and that's what we put there for the value. So just like here, we created a ZIO value, here we're creating a function that uses ZIO. So now we're doing pretty good. We have this ability to read in a username, and now we just have to figure out, well, how am I going to print that username out after we get it back in? And if I happen to show enough code and enough examples earlier in the book, you would know that what you want to do here is kind of that and then thing. So you want to do a read line and then you want to do the print name. So when you start thinking and then in your mind, what you want to do is start thinking about flat map. So this would be flat map. And then again, this part here is going to be an anonymous function. So we can think that the name variable is coming out of flat map and it's going to come into the anonymous function body right here. And now what we want to do is just say, I want to print name that name, just like that. So again, this is the body of our run function. And again, run in the ZIO world is analogous to a main method in the Scala world. So coming over to the book, I discussed the keys to the code in this area. I discussed the run value already, so I won't go into that again. In this example, this flat map is the new unique piece. And as noted over here, flat map is the mechanism that is used to run functional effects in sequence. So that's what we're doing here, is we're running this effect right here, and then we're running this effect in sequence after this one is run. And when I think about code like this, I always come back over here and note that ZIOs are described as blueprints for running concurrent workflows. So if you imagine that any of these effects over here, this one or this one, can be run concurrently, then flat map is our way of saying, well, what I want you to do is don't run those concurrently. Run this one first and then run this one second. And flat map is the guy that enforces that. And again, we say that the effects are run in sequence, and what we're doing here is sequential composition. And then I have some more notes here about flat map. And the cool thing is that this statement is true whether you think about the code being run in serial or parallel. And a lot of times I just imagine that everything can possibly be run in parallel. And then flat map means run this one and then run this one. So if I save that and didn't make any typing errors, we can come back up here and do that and say Alvin is my name. And it prints out Alvin this time. So note over here, we didn't get any printout from it, and now we do. And as I noted in the book, congratulations, if you haven't done this before, you're now composing effects in sequence using flat map right here. And now our next step in the ZIO world is to know that if you're going to keep composing multiple effects that need to be run in sequence, you could keep using flat map as I showed in this example over here. But unfortunately, when you do that, it just gets hard to read, as I note right here. So if you have a couple, what do I do here? I have 3 effects in a row. So do this effect first, then do this effect, and then do this effect. And then the body of what you want to do would be down here. But you can see that this nested code is getting kind of hard and ugly to read. So as it turns out, using flat map to compose 2 effects just like this isn't too bad. But when you start getting into more effects, then this code is going to get harder and harder to read. And that's where we get into Scala's syntactic sugar. So I show in the book, and I've discussed this before in this video series, is that this code right here can be written like this instead. And in fact, this code right here compiles into this code. So the Scala compiler might enjoy looking at code like this, but humans find code like this much easier to read. So skipping over the discussion down here, a better way to do this for humans is to say for. So now what I want to do is I want to get that name in the first line. So I want to say name comes from that username value. And then notice the use of the word and then I want to do this. So let me just do this part first, because sometimes it's hard for me to talk and type at the same time. So what you do here is when you have an effect like print name whose type is unit, that means you don't care about the return type. And whenever you don't care about a return type in a for expression, you just use this underscore keyword right there. So anytime you see that in a for expression, that just means whatever this effect is over here, we don't care about its return type, so we're just totally ignoring it. That's all that means right there. So now I'm prompting for the username and reading that into the name variable. And then that name variable is passed here into print name. Then I ignore the return from that. And now we do a yield. And in this case, if I wasn't showing the book over there on the left side, I would ask you what you would put over here in this yield block right here. But since that is being shown, you can see that that's unit. And the reason that's unit is because we don't care about anything coming out of this for expression. All we care about is that we got the username in here and then we printed it there. So this does not have a useful return value. And whenever a for expression doesn't have a useful return value, you return this. This is actually value right here. It's the one and only instance of the unit type. So just like println returns a unit type, this is actually the one and only instance of the unit value over here. So this is saying I'm returning unit or nothing from this for expression right here. So now if I save that and come back here, we can run that again. And I can type in the same thing as before, and there we see the result. So that's pretty cool. If we go back here a page or two, we see that what I was using initially was flat map to do this. And now if I come down 2 pages, we've now converted that flat map to this for expression. So I'm not sure if there's a rule of thumb here, but if there is, it would be that if you're just merging a couple of effects like this together, you can use flat map to sequentially compose those and say, do this and then do this. And then once you go a little bit past that, then you'll start using for expressions. So again, I should say that I'm kind of guessing at a rule of thumb, but I suspect it would be something like that. And I do note that down here is that this is what sequential composition in ZIO looks like. You use flat map to sequence 1 or 2 effects if you want to, and then use for expressions once you start getting into more complicated code. And I should also note that we wrote code like this in the to-do list application. So if for some reason you're coming directly to this video and you haven't seen all the previous videos, you might want to go back to that to-do list application to review it, because I covered for expressions quite a bit in that area. And now our last ZIO application is going to be this one that starts on this page. And before we get into that, what I want to do is come over here and say, Recall how I noted that when you don't care about the environment, you'll pass in an any, and that's the standard way of handling that situation. And when something can't fail, you show a nothing type in this position over here. And I hope in your mind, when I mentioned those things, what was going on was you're thinking, well, if these are standard things that happen all the time, why in the world would I want to type this all the time? So hopefully you had that thought or something similar to that thought in your mind, because that's where we're going next. So it turns out in the Scala world, what we can do is create things like type aliases. And then in Scala 3, we can also get into this thing called opaque types. And what these things do, I'm not going to get into this in the Scala REPL for us, but what you could do just to create a simple type alias would be something like this. So you say, I don't want to use the type double. And actually, you shouldn't use the type double for money, but just in this example, I don't want to use the word double when I'm referring to money. I want to use the word money to refer to money. So now what you could do after you create this type alias right there is you can say, well, now I want the variable $1 to equal this expression right here, which is normally in double, but now because of that type alias, I can refer to it as money. And I should say that this is a really simple example. And if you want to see better ways to implement all of this, I talk about it in the Scala cookbook. And I may also have free recipes on my website. So look for things like the words type alias, and also look for the phrase opaque types on my website, because that's something that's even more powerful that we can do in Scala 3. But anyway, just given this little brief example of what type aliases can do, what happens in the ZIO world is that there are several different types of type aliases, and these are some of the common ones right here. So I'll come back to these in just a moment. But for our purposes right now, I'm looking at this one right here and thinking, why do I waste the characters any and nothing? Because these extra words right here are a load on the human brain. And if we don't have to see those, maybe we could just get rid of them. So that's what these type aliases are going to do. And this one right here is what we call an unexceptional effect. And that's because we're saying with the first one, the environment is not important. And then we're also saying the error type is not important. And the only type that's important is that success type. And so somewhere in ZIO history, that became thought of as an unexceptional effect. And what turns out is that you can replace this long type right here with this UIO. So again, that U right there stands for unexceptional. And as it turns out, then we can delete those other parameters. So you could change that to a UIO, and then you can get rid of those things right there. So again, less typing, but also less reading. And once you get comfortable with the concept of that being an unexceptional effect, then you know, oh, okay, the only thing I have to worry about now is the success type of this expression right there. And the success type, again, from a print line is just unit. So I could save that code, come down here. And now what I want to do is, since I'm starting to import more things, I'm just going to put the ZIO.splat right there, the ZIO.star, and change that to that. And there we go. Our code is still working. And all I did was change this code right here. So it was this ZIO right over here. And now I changed it to this unexceptional effect right over here. And what I did when I first started working with ZIO was I created this as a little bit of a cheat sheet. And once you've been working with ZIO for a while, you'll get all these in your mind. But I started off with a little bit of a cheat sheet. So this unexceptional effect is one of the easier ones to get started with. And again, all you have to worry about is that type right there. And then I talk about another one here called task. So I like to think of some parts of my code as running a task. So I thought the task alias was an interesting one to look at. And as you see up here, task of A is an alias for a ZIO of any throwable in A. So if you don't look down here just yet, a good exercise is to think of what does this mean, this any throwable in A. So as you recall, this first parameter is the environment. So this is our way of saying there are no requirements for that environment. So we use the type any right there. This is something that can throw an exception. So it has the type throwable right there. And then this is the success value right there. And again, I know I'm repeating this a lot, but you can think of this as being the environment that's passed in. And then you can think of this as being the two types inside of an either, the left type and then the right type right there. And now if you're interested in these type aliases, and I expect you will, you can come to the ZIO type aliases page here. And the first one is the UIO right there. And it's at this URL right here at the top. And again, they note that this one is an unexceptional effect, doesn't require any specific environment, it can't fail, it can succeed with an A. And this is how the type alias is defined right there. And when you want to look at the others, just check out these other pages over here. And I will note that this IO1 is interesting because it's a type alias as shown right here. And this means that it's an effect, it has no requirements, but it can fail with an E or succeed with an A. So you can think of this as being useful for any type of input output. So that could be reading a file, writing a file, command line input output. So if you just want to think about file input output or command line input output, that's a simple way of thinking about that now. So I could keep going down the ZIO road and showing more and more examples, but actually what you're seeing right here are the nuts and bolts of this. And since this is an introductory course, I'm pretty confident that I've shown you enough here that you can now go over to the ZIO website and take a look at their website. And as I wrote in the book, and as I believe in this course, my goal was for you to be able to look at those websites and say, well, I know what they're doing and I know why they're doing it. So now if I come over to this page for the ZIO app, and they mentioned running a ZIO effect. If you look at all this code right here, I believe now you will understand this code. And the biggest difference to know about this code is that this is written in the Scala 2 style. So in Scala 2, we use curly braces, just like you do in other languages like Java, C, Kotlin, and so on. And then you also use the curly braces here with for yield expressions like that. Another difference is that in Scala 2, you use the underscore character like this to import everything from the ZIO.io package. And in Scala 3, you could still use an underscore here. That's perfectly legal. But the preferred way now to do it is with a star like that. So those are the big differences between this code. But now if you look at this code, you can see, well, they're using their console object. They're printing this out. And recall that this is an effect right here. Readline is also going to be an effect, and this one is going to be an effect. So they could run this code with flat map. They could say, do this, then flat map this one, and then flat map to this one here. But instead, we use for expressions because they are easier for human beings to read. And when we print output, we don't care about the return type. So that's where that underscore comes from, and that underscore comes from. And I mentioned that this is the unit value right there. So everything they're interested in doing in this code is with these print lines and read lines. So they don't care about the return value from the for expression. So they return the unit value right there. And then as we start going into other code here, they start to show a few more details. And they note that if you want to access command line arguments, you would use the built-in getargs method right there. So the first thing they do is they call getargs and they get those arguments right here. And then they have this if-else expression right here on the right side. So this code block right here is on the right side of this arrow right there. So that's just a formatting thing. This block of code could be over here a little bit more. But other than that, that's all that that means right there. And then if I back up here to the ZIO page that you see over here, they have additional information possibly about everything I just talked about. So they talk about ZIO and these REA types. And if you look here, this is what I was talking about, where they say conceptually you can think about this ZIO REA as being like an effectful version of this following function. So it would be a function that takes an R as its input, the environment as the input, and then transforms that into an either of E and A. So again, you come back here and this says, well, my ZIO needs this R for the environment, and then it's going to return these either values, the left and the right, like that. So if I didn't mention this before, this is why I got into using the either type. So I started off showing you option, which was the simplest type. Then I got into try, and I noted that we use try when we want to interact with the outside world. And then I switched from try to either because I knew we were coming up to this here. So I wanted to use either to get you ready for all of this and all of this right here. And in this video, I don't want to take you through everything else that you're going to see here. These are all things I talked about before. And by now, this type of code right here should look familiar to you. But again, when I come back to the book over here, I wanted you to be able to come to these pages over here and say, aha, I know what they're doing. I know why they're doing it. So now you can see as we're going through these pages, I think you're going to be in pretty good shape for this. I was going to stop there, but let me see if I can give you a little bit more of a tour. So, ZIO succeed is when you want to create an effect that you know is guaranteed to succeed with some specific value. So it's not going to throw an exception or something like that. I didn't get into ZIO.fail, but they show an example of it down here with an exception. If you follow me on Twitter, you would have noticed that around the time of this recording of this video in late January 2024, I shared some of these from examples. So if you have an option, you can actually convert an option into a ZIO type like this. So you start off and you say, well, I have an option inside my code. What can I do with that? And what you can do with that is convert that option into a ZIO type like that. And then once you have it as a ZIO type, you can use it in for expressions with other ZIO values if you'd like. And you should be able to do the same thing with try and either. So some of that is right here. So they talk about either, so you can do from either. And so if I scroll down here, this is an either example. So this creates a ZIO from an either value. So again, imagine you're inside of a for expression and you want to convert everything to ZIOs. This is the way you do that, is with from either. And actually all you have to use is the word from. I noticed that in some recent code. So you don't have to use from option, from either, and then from try. You can actually just use the word from, and that is as of January 2024. So again, note that this one assumes that you have a try value and you want to convert it into a ZIO, and that's the way you would do that, like that. And as I scroll down here, you can also see that you can do that with future types. And there's an example right there. So I'm saying I want to do that from a future. I showed earlier ZIO attempt and ZIO succeed. And now you start to see some other things you could do. So I showed you the attempt part, and now you start getting into more of the ZIO API. So this is just starting to get into more of the ZIO API. So I was going to get into more ZIO code, but I think that the important part is that if you're familiar with Scala, then you can understand code like this right here and this part right here. Also, some of these, like this one, come from the Java world. So if you're familiar with Java, you'll know some of that API as well. And then what ZIO does is it says, we're going to wrap these effects or these side effects inside of something like ZIO attempt. So again, this is something that can fail. So we use ZIO attempt. And then we get into more of the API like blocking here. So I don't want to get into all that in this course, but they have some really good documentation on these pages here. So you can read through these pages as needed to understand more of the ZIO API.